Okay, so one more little detail. If you do start looking into LU with partial pivoting, and you look into how to do that in a blocked algorithm, what you're going to find out is that actually, when you've gotten to this point, you end up having to factor a panel like that using LU factorization, or rather using LU factorization with partial pivoting. And what that actually means is that performing an LU factorization of a rectangular matrix is a meaningful operation. And so far we've only discussed LU factorization where the matrix is square. Well, if you start with a long skinny matrix like this, then LU factorization becomes the computation where you march through exactly as we have done so far, except once you run out of columns, you're finished. And what you notice from that observation is that what you really need to do is change the loop guard to where, instead of looking at the number of rows in the matrix, you look at the number of columns in the matrix. And that becomes your loop guard rather than the one that we've used so far. Now you may ask yourself, does one ever do an LU factorization of something like that? And there the answer is, I don't think so. Although one could envision an algorithm for reducing a matrix to echelon form that itself would be a variant on LU factorization, and there this might actually come up. In practice, people don't reduce matrices to row echelon form in order to do things like find vectors in a null space, etc. In practice, there are actually other methods for that. So that's not something that people would tend to look at. Anyway, I'm getting a little bit off track. Let's just leave it at that.